Welcome. This question 3-sum is an extension to the 2-sum question. If you are not familiar with 2-sum question, it's recommended you review the 2-sum question first. The 3-sum question gives you an integer array nums and asks that you return all the triplets nums I, nums j, nums k, such that the three indices are not the same and their numbers sum up to be 0. And importantly, the solution set must not contain duplicate triplets. How do we come up with the answer? Well, when you face a more difficult question like this, it's crucial you leverage what you already know. So in the 2-sum question, we already learned that we can use 2 pointers in 2-sum 2 question to solve for the 2-sum. So if we can just fix one of the indices, such as I, and then reduce a question to a 2-sum question, solve for j and k using 2-sum 2 function, then we can have a solution. More specifically, if we iterate through the nums array for I, and then each time we call the 2-sum 2 function, which has a time complexity O(n), then for 3-sum, we can expect to have a time complexity O(n) squared. Okay, so with the background knowledge introduced, we are now ready to write the code. So first of all, we need to define a 2-sum 2 function. Take one argument, the fixed value of I, and for the nums array, to work with the other function, which is self variable here, and that's none, and we also need to sort it first. And this sorting has a time complexity, I think it's n O n log n, and the space complexity between O log n and O n. And here, 2 more number is the, remember we are shooting for nums ijk. So the I will be the, the j will be the next number, the next element, and k will be the last element in the nums array. And we're going to use a 2 pointer to find j and k. So while j less than k, the sum equals to the 3 numbers sum up together. And if their sum is 0, then we have our answer. And also we need to create another variable called the result, and then we append the result with these 3 indexes, their numbers. Okay. And if the running sum is let's say larger than 0, we know we need to decrease k, and if running sum less than 0, we need to increase j, and so we iterate through I, because we know the upper limit is -2 here, since the last 2 must be j and k, so it's -2, and we call the 2-sum 2 function and provide it with I. And finally, we return the result. And to take care of the requirement that the result must not contain duplicate triplets. So we want to make sure, let's create a previous number, and if this previous number, or this previous number will be assigned after we run the toSum function. If the previous number I, previous nums of I, if this previous nums of I is not the same as the new nums of I, then we proceed. Also, we know that if this nums of I is larger than 0, then there's no way, since the nums are already sorted, there's no way the sum can be equal to 0, so it must be upper limit to 0. And so this allows us to find the next unique num size. And here we want to find the next unique num j. So how do we do that? So after we append this, we also want to increase the j, but we want to make sure it's unique. So while j less than k, and it's not the same. Also, we want to make sure it's not the same, but so if it's the same, we'll keep increasing j. And this is our answer. Okay, so let's submit. Pending and charging. Let's see, accepted. So with 764 milliseconds, pretty good. So we're going to analyze the complexity. So the overall complexity, since we iterate through the whole nums array using I, and the toSum also has ON time complexity. So the overall time complexity will be ON squared. And then the space complexity is primarily dominated by the sorting algorithm. So it's between O log n and ON. While we ignore the memory requirement for the result. For now, we focus on n. So that's all for this question. Hope you find it to be useful, and see you next time.